Hello everyone, this is Rakshita Joshi. Today, me and Sachin Rawat are going to present the topic Conductivity Mechanism of Polymers, in which we are going to talk about basic introduction, charge carriers, band gap theory, and p doping and n doping. Let's start with introduction. There are many organic polymers which are used as electrical insulators, for example, Teflon, polyethylene, and PVC. The conjugation is the main reason for conduction in polymers. In saturated chemical structure, all the valence electrons are strongly localized. These electrons do not contribute in electrical conductivity of materials. But due to extensive research work, scientists are able to synthesize conducting polymers. Polyacetylene is the first example of synthetic conducting polymers. Now let's see the types of conducting polymers. Firstly, conducting polymers are divided into two parts or two types: intrinsic conducting polymers and extrinsic conducting polymers. Conduction is in intrinsic conducting polymers is due to extensive conjugation in backbone of polymers, and intrinsic conducting polymers are basically blended and the blends are responsible for conduction. These both are further divided into two parts. Intrinsic conducting polymers are divided in conjugated conducting polymers and doped conducting polymers, and extrinsic conducting polymers are divided in polymers with conducting elements and polymers with conducting blends. Now let's talk about the charge carriers. In polymers, charge carriers are mobile entities which are responsible for carrying electric charge. These can be electrons, holes, or ions. In conducting polymers such as polyacetylene, these carriers facilitate electrical conductivity through the material. Solitons, bipolarons, and polarons are all the types of charge carriers in conducting polymers. Now let's talk about solitons, bipolarons, and polarons. Solitons are localized wave-like disturbance in the polymer chain. Where the electrons are delocalized, solitons are associated with movement of charge along the polymer chain. Now let's talk about bipolarons. Bipolarons are formed when two solitons are close enough to interact and become paired. This pairing reduces the overall charge of the system and can affect the conductivity properties of polymers. Now let's see the polarons. Polarons are charge carriers formed when an electron or hole polarizes its surrounding polymer chain due to its presence, causing a distortion of molecular structure. This distortion effectively reduces the charge's mobility within the material. Each of these charge carriers play an important role in electrical conductivity and each electronic properties of conducting polymers. Thank you. Now I would like to invite Sachin Rawat for further explanation.
Now, thanks Rakshita. Before I present my topics, I would like to thank Rakshita Joshi for making this presentation. Now, before explaining the band theory regarding this, I would like to explain some few basic concepts like valence band and the conduction band. So, the electron that lie, as you all know, the electron that lie in the outermost shell of an atom are called as valence electron, and they cannot take part in conduction and are said to lie in valence bond. Whereas the electron that are free from an atom and can conduct current are said to lie in conduction band. So, in band theory, according to this theory, in case of insulator, the forbidden gap between the valence band and the conduction band is more than 3 electron volt, while in case of semiconductor, the forbidden gap is moderate, and in case of conductor, the forbidden gap is negligible, as we can see in the following figure. Now, in case of conjugated polymer, the forbidden gap can be decreased by introducing charge carriers through doping. This process facilitates the conduction in conjugated polymers. Now moving on to the first doping case, that is p-doping. So in this type of doping, the polymers which have conjugation in the backbone, when treated with electron deficient species such as Lewis acid like FeCl3 or iodine vapor or CCl4 carbon tetrachloride, there takes place a oxidation and a positive charge created in the molecule, as we can see in the following figure, like how the polyacetylene converts into a polarone, bipolarone and a solitone. So, in this mechanism, there is removal of one electron from pi backbone of a conjugated polymer forms a radical cation, polarone, as I mentioned earlier, which on losing another electron from bipolarone, the delocalization of positive charge cause electrical conduction. Now, the second type of doping is N-doping. In this case, when Lewis acid, like electron-rich species, are treated with polymers with conjugation, due to reduction of polymers, a negative charge develops. So, in this mechanism, as it is shown in the figure, the first step is the formation of polarone, and the second step is the formation of bipolarone. Actually, by addition of one electron polarone and by addition of second electron bipolarone are formed. So, in bipolarone, due to delocalization of charge, the conduction takes place. And thank you